Okay, so this is the poly and sinusoidal review quiz. Okay, so question number 1 says use the following information to answer the next 2 questions. So we have this function. We want to know the degree of this polynomial function. Well, it's clearly a cubic function, right? So the degree is 3, right? X cubed. It says determine the number of turning points of this polynomial function. Well, we have 1 there and 1 there, so it is C, 2. Okay. Alrighty. Question 3. Determine which statement is false. Maximum number of x-intercepts on the graph may have is equal to the degree of function. That is true. Maximum number of turning points a graph may have is equal to 1 more than the degree of the function. That is not true. It's actually 1 less, right? Degree and leading coefficient of a polynomial function indicate the end behavior of the graph of the function. That is true. And the constant term of an equation of a polynomial function is the y-intercept of its graph. That is true. So the answer for 3 is B. Question 4, we have this scatter plot. It says what kind of relationship might there be between the independent and dependent variables in the scatter plot? Well, I don't see a linear relationship. I don't see a quadratic relationship. I don't see a cubic relationship. In fact, I don't see much of a relationship. It's a pretty scattered scatter plot. So the answer would be none of above, because we're not seeing any general trend of a straight line or of a parabola or of a cubic function. Okay? And sometimes data doesn't have any concrete relationship that we can sort out from its information. Because, I mean, we now know about sinusoidals, and it doesn't look like that either, right? Okay, question 5. Using technology, determine the equation of the linear regression function for the data. So you're going to put this in for a linear regression. So this will be in L1 and L2. You're going to find the linear regression using your calculator. When you do so, and this is question 5, sorry, what you will find for your equation is G. 141.8 minus 3.9x. Okay, so if you don't know how to do a linear regression, come early tomorrow and we can go through them between 12:40 and 1 o'clock, and I can walk through linear regressions with you. Question 6. Hint, use diagnostic and R2 value to help you determine which regression to use. So we have some data here. The interesting thing is, remember, I always say time needs to be your x values. So this would be in your list 1. So that means volume is your y value, and that'll be in L2. So you're going to put this data in, and you need to have your diagnostic on, right? Diagnostic, I've even hinted to find your R2 value. Because when you put this in and you do a scatter plot, you get a graph, or the plot looks like it could possibly be quadratic, or it could be cubic. So you're going to want to use your R2 value. There's another clue, however. Here it says cubic centimeters. When you do your R2 values, you get a very high number for quadratic, but for cubic, R2 is literally 1. So that means you're going to need to do a cubic regression. When you do it, you put in all your values, and what you get for your answer is C is equal to 8.81.5. Okay, you want to determine the volume of the balloon at 10.5 seconds. So once you get it, you put in 10.105 seconds. You're going to need to change your window settings, because these right now it only goes up to 4. So you're going to need to extend your X max, and they recommend 12. That will give you a nice room. You probably also will need to change your Y max because right now it's only configured for 904. And look at these values. They want you to go up to over 8,000. Okay. Question 7. So we have this function up here. I'm going to highlight it because it's kind of hard to see with my many copied thing. But we have a equation up there, which is basically y equals 4. This is a constant function, right? There is no variable. So that means the degree of this polynomial function is 0. Okay? Alrighty. So if you ever see a horizontal line, degree is 0. Question 8. The path of a shot put thrown at a track and field meet is modeled by the quadratic function given, where h is the height in meters and d is the horizontal distance in meters. To the nearest tenth of a meter, the height of the shot put when it has traveled 10 meters horizontally is. So, let's see. D is our horizontal. I'm just going to highlight here. D is our horizontal distance. So that's what we're looking at, right? And that would be our x value. And h is the height in meters. And we want to know the height of the shot put when it's traveled 10 meters. So we're going to take this formula here. And all you have to do, you can either put it in your calculator as a y value and use the graph to find it, or you can substitute in x equals 10 and solve for your value for h. Okay, when you do that, question 8. You should get 6.4. I'm going to do it real quick here because I'm looking at the key and I just want to make sure that I've got the right answer. Okay. So I'm going to put in this equation, negative 0.048 bracket x squared, squared, minus, you guys must wonder what I'm doing when I say oops. It's basically I'm pushing the wrong button. Minus 20.7d minus 26.28 close bracket. And I want to graph this. Oops, my scatter plot's still on. Sorry, I was doing some other equations there. Enter. And then I want to change my window. Let's see, I know my x has to be at least 10. So that'll do. What do I think for my height? Sorry, momentarily paused while I put in new windows. I'm going to graph that. And I want to know what the height is when x equals 10. So I'm going to use second function trace value, x equals 10. And yes, I get 6.4. What I actually get is 6.39744, but it says to the nearest tenth of a meter. So I round to 6.4. Okay, interesting range of answers, but 22 of you got that right. Sorry, question 9. The weather in St. Louis is suddenly affected by global warming and the temperatures throughout the year increase by 5 degrees Fahrenheit. The climate change will result in, well, if we have a graph of our weather and it looks like so, generally we start chilly in January and we get warmer in the summer and then we get chilly again in December. If all the temperatures increase by 5, that means the whole graph is going to shift up by 5 degrees or 5 units. Okay, so we're basically just increasing the temperature 5 degrees all the way along. Okay, so that's more of a thinker. Okay, Question 10. The hours of daylight in Edmonton over the course of the year can be approximated using the following sinusoidal equation, where y equals the hours of daylight and x represents the number of the month. So January 1st is 1, February 1st is 2, etc. The number of hours of sunlight on April 1st is, so April is the 4th month, so that means x equals 4. So you just need to substitute in 4 for x. Whether you graph it or not, you can substitute it in and calculate your answer. But what you should get when you substitute it in, so you make x equals 4 and you'll solve for it, you should get F, 14.6 hours. Okay, so in April we start getting longer days, really. Okay. Well, we actually start getting longer days in December, but you can feel it more in April. Question 11. Fred is riding on a Ferris wheel at capital X. His height above the ground is given by the following function, where h is measured in meters and t in minutes. So h is meters and t is minutes. In one rotation of the Ferris wheel, Fred is more than 35 meters above the ground for how long? So when you graph this, it's a sinusoidal wave, right? Starts down here, goes up, goes down, goes up, goes down. And we want to know how long he's up above 35 meters in one rotation. So you put your graph in as y1, so this will be y1. And then you're going to do a y2 equals 35. So what will happen is you'll get a line in here for your y2. Now, anything above there is above 35 meters. So once you do that, you're going to use intersection to find this point and this point. So you're going to have x1 and x2. x2 minus x1 will give you the amount of time that he is above 35 meters. And what you're going to find is that it is 2.08 minutes. F. Okay. Alrighty. But you'll use intersection to find those 2 points. Alrighty. Jessica graphed the two functions y1 and y2 on her graphing calculator. Her calculator screen is shown below. So she's got the two functions graphed there. The two graphs differ in, they do differ in amplitude, but the period is exactly the same. Okay, so they don't differ in period. So this is not an answer. So obviously this is not an answer because period is there. And we know amplitude is correct. Okay, horizontal shift and vertical shift. Well, they're if we look at this, they are lined up perfectly. So there is no horizontal shift. There's no shift one way or another. And we can also see that we have crossing points, right, that match up. And vertical shift, well, there is a bit of a vertical shift as well because they have different midlines. If we drew a midline in for this one, it's for the lower one is right along the 0, but for the upper one, the midline is closer to here. So there is vertical shift. So that means that H is our only acceptable answer because we have vertical shift and we have amplitude that have differences. Okay. Question 13. While his son was on a roller coaster, Jacques recorded his son's height above the ground at 1 second intervals. The data is given below. Using a regression equation, so you know what you have to do, you've got to use a regression equation. And you're going to use C sine reg, right? Because this is definitely, it's a Ferris wheel or a roller coaster. So it's going to end up being a sinusoidal regression. Jacques found the height the maximum height to the nearest tenth of a meter that a son will reach while riding on the roller coaster is how many meters? Record your answer in the space on the answer provided. So you put that in, you do your regression, and what you'll find is the maximum equals, and one might think it's 11.4, but it's not. It actually works out to be 11.3, I believe. I want to double check my answer. I'm going to do the work here. I'm going to type some stuff in. So question 13 is, yes, 11.3. So you have to do the regression equation to find what that peak is, but that's what it does work out to be. So he's clearly starting to go up on this curve, right? I believe you actually get 11.33, but it says to the nearest tenth. So you round to 11.3. Okay. Question 14. Ida graphed the function as given and made the following observations. The period is pi, the amplitude is 3, median is 3, function has been shifted downwards, and the maximum value is -7. So let's find those and see what we're talking about. So, and we'll find out, we're basically marking whether they're true or false. Oops. I went way back. Here we go. So, period. Well, that's going to equal 2 pi over b, and b is 2. So the period is pi. So this one is true. The amplitude is 3. Well, yes, A equals 3, so that is also true. The median is 3. No. The median is D, and it's equal to -4. So that is not true. The function has been shifted downwards. Well, yes, because normally the median would be at 0, right? For a sine function. So this has been shifted. Normally it would go, right? Well, we've shifted it downwards so that it starts at -4, right? So, yes. So that is correct. And the maximum value is -7. Well, max is equal to, -7 plus the amplitude, right? So, sorry. I'll write this out in formula way first. It should be D plus A, so -7 plus 3. So the max, -4 plus A. Sorry, I was over extrapolating. So the max is actually -1. Okay? So that one is not true. So from there, the true statements are 1, 2, and 4, and that's the order you put them in. Now, I think I put it in where if you put commas, you still got it right. I'll double check in case that is not the case. Yes. So, and if you had spaces, it still should mark it right too. Okay? But it's a matter of ruling it out, finding the real answers and ruling them out if they're wrong. The graph of a sinusoidal function of this form is shown below. 4 points are labeled. The equation that best fits this graph is as follows. Now, how I did this? Remember, we can find our amplitude and our midline. Now, our midline for all of them is actually 30. If we put our midline in, we will find that or our midline for all of them is 30. So we can't use that, right? So D equals 30. We know that. They all have that. But look, they have different amplitudes. So let's find out what the amplitude is of this. Well, it's the distance from the peak to the midline. So that's 1, 2, 3, 4. And this goes up by 5s, right? 5, 10, 15, 20. So A equals 20. So that means this one and this one are incorrect. So here's what I did. I put in these 4 points in a scatter plot, right? I put them in a table and I put them in a scatter plot and plotted them. Then I put in this one as y1 and this one as y2. Only one of them went through all the points, and that's the correct answer. So the correct answer turned out to be C. There might be another way that you can kind of determine that, but when I put it in, what I discovered is that the only one that worked is C. Now, important to note for the sine function, it's not going through 0 and it's shifted from there, but it's the 30 that's moving it, right? So if you can match up to the points with one of your lines, and if you plot them in as a scatter point, you don't even have to do that. You could just put in one line and then test those points by putting in the x values and seeing if all 4 of those points are on by trying 0, 15, 35, and 45. And then putting in the other one and testing it. Basically just ruling out, using your technology to help you. Okay, you can always use your graph, your graphing calculator. And then last question, 16. The graph of some periodic data is shown. What is the period to the nearest whole number? So what we need to find is from point to point, right? So we go across here to here, and looking at that, 1, 2, 3, 4. 4 units. So our nearest whole number is 4. Now, you can try different matching points. So, for example, I could have used this point to that point because those are periodic repetitions. And again, it's 1, 2, 3, 4, and we get the same answer. Okay? In fact, any of the matching peaks will give you a 4. So here to here will give you 1, 2, 3, 4. Okay? So you're just looking at where does that periodicity repeat? How many points over? Okay? But if you take those peaks, it will still give you the right answer. Peaks or the